Hello and welcome back to a new video in my C++ tutorial series. In the last video, well, we were experts for numbers. We got experts for numbers. We learned the hexadecimal system, we revisited all the binary and decimal stuff, learned how to enter them in C++, learned how to use a Windows calculator, and yeah, that was fine, very fine, and we learned many things. And yeah, today we're gonna do something completely different. Like, the numbers were very important to understand, and we now know exactly and are exactly experts with normal, decimal, and binary and hexadecimal numbers. So we are number experts. We know how we do calculations with numbers, which we have proven here. We know how to do them, we know how to print them, we don't know how to input them yet, but we're gonna get to that in a future video, which is gonna actually take a bit of a time because the function that we need to use to input numbers does require an important concept that we maybe do next video, that we're probably gonna do next video. Next video is only gonna be about pointers. This video is not gonna be about pointers because pointers are actually not that simple, but yeah, today we're gonna have a chill video. Today we're gonna have a video about functions because, well, we already talked about functions. This might be feeling very unnatural. I think it was the first video where I already explained what a function is. So I've explained to you that we have implemented a function main, and I've explained to you that we use the function printf. And in additional videos we talked about where the printf is coming, that it was coming from the stdio.h header. Then we basically talked about how we can use this properly, this printf, and we talked about functions. About functions like we're always there. But this video today is now going to be completely about functions. How we can do our own functions, what we do need to take a look at if we write functions, how return types and return values of functions work, how arguments work, and today is going to be a nice video about functions. So, what are functions? Functions are basically containers for code, and I already told you that C++ and C always needs a container for code. You cannot have floating code. I cannot have like a insert into t xy equals 5. Okay, actually I can do that, but like, what I cannot do is basically have a printf here. I cannot printf xy here even through, like, this seems to be legit and working, but you can see, like, it's not really working. If I try to build this, expected that type, specifier, syntax error, string missing, whatever before string missing that, variable xy is not a type name. It's really not working. I already told you that in C we always, and it also in C++, we always need a container for our code. And the most basic container for our code, and easily actually in C the only container for code, is a function. So the function that we defined here is main, and the name of the function, main, function main, name is main. The name main basically was a magic value that was like used by the linker, so the linker searched for a main function called main to call when the application starts. So we had some magic salt around here that basically made our code work. And we blindly typed the int before that main, int space. We now know what int is. We had a video that we really don't want to use int, but we talked about what a int is. We know that it is a type, and we basically have now a type, main, and brackets, and yeah, it's doing some stuff. But now let's actually get to how a function is actually built up. So we already have like this nice main function as an example. But, well, we do want to write a different function. We want to actually now write this function, the f from x. That's basically what we processed here, was the function f from x. And I actually now want to implement f from x not as an inline statement. So basically here I used an inline calculation, a single line, to calculate that, to basically compute that function. But if I now want to compute that function again, like for example if I might want to have an insert to t from y2, so 2 times y, or yeah, y2 basically by 2 times x, I would now need to go in and write 2 times x times 2 times x plus 5 times 2 times x plus 5. So if I would want to reuse that function, I need to completely type in everything again, and it's really looking a bit ugly. You cannot really see that this is the function x. I mean, these two are still the same functions that are going to be invoked, but once I'm invoking them with y, and the other time, or with x actually, one time I'm kind of like using this mathematical function with x, and the next time I'm using the mathematical function with 2x, but they seem completely different. They seem like complete different different functions. And it's kind of true because we're using like 2 times x here. But, well, yeah. To get a point, like it's not really useful. We have to always rewrite the function, and if we would change something here, so if we would add another x in here, so 3 over x, if we would do this like that, well, we need to change every time this function occurs. So we always need to add code, add more code, and it's gonna get unmaintainable very, very quickly because you always need to duplicate stuff and you need to work at different places. So ideally, for having a nice programming style, there should be only one location where we need to change our function from x. There should be only one location where we need to change it. And everything else should automatically change as well. This would be an ideal code. We already follow many patterns. At least if I get rid of that, we already follow many nice patterns that we need to do for having functions. Well, short and descriptive names, x and y. In this case, totally fine because we have an x and a y coordinate that we want to compute. And the simple print statement, very readable, very short, it's very comprehensive. And our code, even if we would not have these comments here, actually there are people that state that code without comments is the best code. If the code is as simple that you can understand it without having comments here, it's actually fine. And this is something where we're gonna step by step gonna go to, but still I'm gonna have comments in here that explain stuff for you because you are new to C++ and C. So, well, how do we get that code duplication away from here? How can we do this? And maybe now the new requirements is that we have an int32t y2 equals something, and an int32t y3 equals something. And yeah, basically the requirement is that we compute f from 2x, and f from 3x. These are now the new requirements for processing. So how do we gonna make this that we can do this very simply? Basically what we're going to do is we're going to factor out our f from x into a function. So ideally what I want to do is I want to be able to do something like that. Well, 2 times x, f from 3 times x, and above here, ideally I would use something like f from x. So this is basically the ideal case. I can comment this out here to what we want to get. This is the final result that we want to archive today. How can we do this? Well, we define ourselves a new function. So basically, main, we use this as a function for our code. We use printf as a function for outputting stuff. And now we want to create a function f from x. So how are we going to do this? Well, the function is going to be named f. And well, we learned that a variable was basically declared by something like that. This is where basically how we declare a variable. And actually declaring a function is completely the same. We completely do it as the same as that. The only thing that's going to change is, as you already see, we use from the main because we want to call it. We need to add brackets, and by adding a brackets after these names, the normal brackets open and close after the name, basically introduce that there is a function called f. And I basically now copied this int32t from like the declaration of int. And this int32t is nothing more than the return type. The return type is basically the value that the function, or the type of the value that the function is returning. If our function does not require to return anything, you can type in void. Void basically means this function is not going to return anything. And if we have a void function, well, it's very simple. The only thing that is left to do, because this basically just tells the compiler there is a function which returns nothing, and by the way, even does take no arguments, called f. So this is basically the most simple thing. But what we of course need to do is we need to add a function body to that. So an implementation, and we do it completely the same than we have did it by the main. Instead of having a semicolon, we use the curly brackets to basically tell the compiler, hey, this is what f is going to do. So basically what we're going to do here now is we're going to say, okay, f is doing that. And well, we could just try to leave this empty for now and see where we're gonna get issues. Well, let's try to compile this. You can also compile this by pressing Ctrl, Shift and B for build. And if I do this here, it's gonna give us something. Okay, it's gonna give us multiple errors. So if I double click the first error, you can also see that we now get this nice little pointy white arrow on the line where the error was introduced. Void, illegal with all types. So what is the issue here? The issue is a bit cryptic what's going on here. basically what's wrong is how the function is used. So basically by having or our function defined as void f from open bracket, close bracket with nothing in that basically means that our function f basically looks like that. Mathematical, this function would look like that. It would just look like that, f. But what we want to actually archive is we want to archive y equals f from x. This is basically our to-do, and this is what we get here. So this is our is. This is currently our state. Our state is basically a floating f, and the to-do is that we basically have an x as a parameter and the y as a return value. So the function should return something. And the return value, I already told you, is basically the type that you write before the function starts. So if I would match this to the types that we already have, I would paste this basically in and would say int32d f from that. And you can see that already some errors disappear. If I would now build, does it work? Yeah, it actually worked. We still get some issues here and it will not work, but at least like the function now seems legit. In C++ this wouldn't work yet because C++ is very strict when it comes to functions. It really asserts that everything is as expected. So we're still going to work on that until we are done and executing that. So basically what we have now done is we have defined that y equals f. But we are still not at our to-do. So our to-do is that we basically say, okay, y equals f from x. So the x is still missing. How can we actually see that the x is missing? Well, we could try to do this calculation. So I'm going to now cut the calculation from here, Control X to cut, and I could try to compute this. So int32t, y equals that. So just paste this in, and it seems good because this is the exact equation that we used. So now you can basically see, if I would now try to, let's try to recompile this, and we get an error. If we try to recompile this, it doesn't work. It says x, undeclared identifier. Why is that? Well, because we, as a to-do, we basically need the x in here. And how can we pass a value to a function? Well, it works very similar. As well as we kind of like declared this variable, int 32t x. This is basically how we defined inside of our main that there is a variable called x, and we can use the same concept here in the function. So we have these brackets that we later also replicate here to basically give it parameters. And in a function declaration, you can basically tell, hey, this function is going to take an int32t, so a type and a name. So basically this tells that the function's parameter x is from the type 32d. And now you can actually see, so we are at the exact state that we want to have. Our to-do is equal to our current state. So let's remove these dumb comments and save the file, and it looks good. So now let's try to build this again with Control B, and let's see what's going on here. So, well, you can see that we are actually here at build, once succeeded, but we actually had an error here in the output. It was actually not an error, it was a warning. The warning C4716, and then if I go to the error list, you can also see it as a warning. F must return a value. That is a warning that we get. It's a warning, we can easily skip over that, and it would still do its things, maybe. It actually does do the right thing. It says that 5 equals 55, and that's actually quite surprising that it is the right value, or it might actually not be surprising because the way C works, but it seems to work. It seems to work, and it seems that everything goes fine, and in our case this might be the case that everything is good, but this can break very quickly. So the one thing that we are missing is basically exactly what it told us here in the list, which is not now telling us because we started it and it cleared the build output. So if we would want to get this warning again, you would need to go to build and rebuild solution. Rebuild is going to recompile everything and brings us back the warning that we had during compile time. So F must return a value. So returning a value basically means giving back a value as a return type. By default, we don't give a value back, and in C++ we would not be able to compile this because C++ is way more strict about functions than C is. So in C++ it would stop with an error saying that the function did not return anything. So we need to add a return value here. And how can we return something? Well, it's very simple. We just type return and then the value that we want to return. The value that we want to return is stored in y, so we type in y. Of course, we could like also return a static value than 55, but this is of course not really what we want. So what we want to return is of course y, so y like that. Okay, so that seems good. So return y, and yeah, that's nice. Before we're gonna rerun this, I want to quickly add a few more arguments. So I want to add a bit of a duplication, and I want to kind of like output this a few more times. So I want to output x, y2, x, y3 like that very quickly, so that we get all of the function values out here. And if I would now run this with a 5, you can actually see that we get x as expected. So, oh, actually not. This is actually like 2 times y, 2 times x and 3 times x, like that. And if I would now run this, now we should actually get the right values. Yeah. So we now get f from 5 equals 55, f from 10 equals 155, f from 15 equals 305. So you can see, yeah, this nicely works. So yeah, that's how functions work. You give it a return type, and to return value to that return type, you type in return and the value that you want to return. You give the function a name, and inside of the brackets, you can give the function arguments. It's possible to give it no arguments. You can give them as many arguments as you want. You can give it an x2, an x3, an x4, whatever you want to have. You can give it as many arguments as you like. And yeah, that's basically how functions work. Return type can be void, so that it doesn't return anything. It just can be a plain insert32t, and as we expected it here, and it's nice. So now we're basically done for the video. We archived everything that we want to do, but of course, you know me, we want a bit play around and improve our code. So first of all, this is really unnecessary. We are creating a new variable called y in that function f, assign a value to y, and then we return y. And y is not going to be valid as soon as we go out of the function. You may also note that the variable y in that function has the same name than the variable y in our main function. This is because variables are only valid in the current so-called scope. We're going to get more to what a scope is, because scope are a bit more advanced than just inside of functions. Scopes basically, a scope of a variable starts when you define it. So basically the scope of this y starts at this line where I defined it. So from now on, the scope of y is valid, and y is basically assigned to the value here. Y goes called out of scope as soon as we kind of like exit the current block of execution. And the current blocks of execution is always nice to determine at the next closing curly bracket. So as soon as we have like this curly bracket that closes here, y is basically out of scope. So this is basically the end of the scope of that y, and as soon as we are kind of like here, y is no longer defined. So if I would want to use y down here, so if I would go in like my main and say x equals 5 times y, it would no longer work, because the y from above here already got out of scope here. So this is basically how these scopes work, but scopes also work differently. I could also do something like that. I could open up some curly brackets, just random curly brackets here. And this would also be a scope. So here you can see I defined y, it's equal to that. And as soon as I close this curly brackets, you can see y gets underlined because it's no longer defined, because we have created here custom scope, and y got out of scope as soon as we kind of like close this curly bracket. Like the scope here is not really useful, but sometimes you want to have things like that to have like your own scopes defined. But in our case, that's certainly fine how we do it here. So just to recap, basically this y basically here is in the marked area in scope, the y2 is in that area in scope, the y3 is in that area in scope, and the x is in that area in scope. So basically, as soon as you define it here, it's going to be in scope as soon as you have like a closing bracket. One thing that you don't need to mistake, if I would have a scope in here, this doesn't mean that the x goes out of scope here, because it was declared one scope above. So basically what you would do is you would kind of like count here. So by default, like this x would be like starting with one scope of reference, then you have like an open bracket, would mean that inside of here x has like 2 scopes of reference, and as soon as you are like closing a bracket, the scope of reference like decrements again. So as soon as we have this closing bracket, we only have 1 scope of reference, and the final closing bracket here decrements the scope of reference from x to like 0, and then x is no longer defined. So it's kind of like it's always like stopping at the layer it is. It's not always like ending up. We can like have infinite number of scopes, and x will always be valid down here because it's like all declared over this. But as soon as I move like x inside of here, it's out of scope down there because it's inside of these brackets. So it's actually quite logically if you take a look at this. So as soon as it's kind of like, if it is like more intended in talking like of tabs, because scope actually, tabs are not an indication because I can make a tab like that, you get the point. But we always like to have our scopes indicated by tabs here, the tabulator key. So this is kind of like how the valid things of that work. So this basically means that the y here and the y there is not the same y. Even through at the end, the value that we computed in here is going to be assigned to that, but they are not the same y. So just having them as y here does not mean that they are similar. This is just because the same name of y, the same concept of y is used inside of the function as well as outside of the function. That's important to catch. So as you can see down here in the function, we are creating a new variable called y, and we are assigning it a value just to then return the y value. And how this actually works is very interestingly. So how are these numbers stored? The numbers are stored on the so-called stack. So let's indicate the stack at the top of the application. So in our stack, we basically enter our main. And as soon as we are in our main, we basically put x on the stack. We then put y on the stack, which is now currently like, let's call this empty, or let's just put a few question marks. Here we have like the x, and it's going to be assigned to 5. Then we put y on the stack, and it is equal to question mark. Then we go inside of our function f. So if we go inside of our f function, the f function is going to put a y on the stack again, which is now equal to some function. Let's call this f from x here, or 55, just to make this a bit easier. So this is going to now put like 55 on that y on the stack. Then this y is basically copied. Now this y is copied to a special location. Now we are returning from the function x, which means that all of that is deleted. So we are going back to that. But y has been stored in a special place. Best return basically stores the value of y in a special place, which can now, since we return from that function, be assigned to the y here. So now y is 55, and then it goes on. y2 is on the stack, which is an invalid value. Then we go again inside of f from x, which is again like basically putting y in here, assigning it some value. Then we basically return from the function, so y is stored on the special place. Everything else is like deleted from the stack. And now we are back here. It's going to be read from a special location, and we have the value in here. We continue on the stack, and we're going to go to y3 equals to whatever, and you can kind of like see this growing in kind of like a tree fashion, and the data is kind of like stored there in that stack. And basically what this means is that we are currently copying y to the stack, assigning some data to that y. Then we're going to store this again to a special location. We're going to delete it from the stack. We're going to return to that, and we're now going to write this back. So there's actually no point in writing this y like that. Of course, the compiler, since it's the Microsoft Optimizing compiler, is going to make this different anyways. So if you are on a Microsoft compiler, it really doesn't matter how you write the function, because the compiler is going to make it optimal anyways. But there's really no point in declaring a variable here. It's just making the code more unreadable. So what you can actually do is you can take that full equation here, delete that full variable here, delete the return of the variable, and paste the full code in here. So this actually works. You can directly return in like equation. And this is not returning, oh my god, this is not what I definitely wanted. So this is not returning the equation. So this is not returning like a function. This is not returning the function. This is actually computing the value and then returning the value. So it still behaves the same than what we had before, just that it doesn't like store that y on the stack. So it's basically just computing them on the CPU, storing that in the special location, which is actually on the CPU directly, returning to the main function, and then it is copied to the position where it needs to be finally stored. So this just makes it a hell of a lot easier. And if we would run this, we're going to see that this doesn't really make a difference. Our values are still the same. Everything's still in place and working fine. All right, so now there are people's conventions and how people like to write code. And there are people that say, okay, in the main file, the main function should be at the top. And every function that is like used the main should be on the bottom. This is like a convention, so that's actually quite fine. So let's say we want to follow that convention, so we're going to have main at the top and f at the bottom. And if you have paid attention to the other videos, you're going to know what issue we're going to get. But I'm going to try this anyways. It still works. This does work in C, what I now tested, but in C++ this is going to fail. Why is that going to fail in C++? Basically, as I already told you, basically what the C compiler does, it takes a look and sees, okay, f is being used with an integer, an int32t. So I'm going to assume that there is a version of f that returns an int32t and takes one argument as an int32t. And later on, we already supply this function. So in the C compiler, this actually works. But the C++ compiler, as it reads also from top to bottom, the C++ compiler will see, okay, I need a function called f, which takes an int32t as a parameter and returns an int32t. I'm not aware of a function like that. I'm going to abort. And if I would go to my Solution Explorer and quickly press F2 to rename that to CPP, And to run this, we want to get this issue. So F, identifier not found. It doesn't know a function like that. So same issue, C++, it doesn't know that function. So how to resolve this? We already talked about this. We basically need to tell at the top, we basically need to tell the compiler how the function looks. So this tells the compiler how the function looks, and later on this applies the implementation. And if we do this like that, press F5 with C++, it works and it gives us the values. Okay, so now let's transition back to C, because C really didn't care, but I still want to follow these conventions. Still works the same, everything fine and good. So now we have the function down here, and yeah, it seems all nice and legit. Okay, very interesting, very nice. So now that you know how a proper function looks, and you basically also know that main is a function, you're probably gonna have a few questions now, because we always use main for granted, and we always used main as is for granted. So we always took that main without really questioning what's going on here. And well, basically what I told you now is that a function has a return value, and that this return value is returned by using the keyword return. And I also told you that we don't use plain int, that we will rather use like int32t or int16t, 64 or int64t or any of these proper integer types. And now if we go back to our main, there are going to be two things that you're going to have to complain about. So first of all, first thing that you should complain about is that int here. We use the normal plain old int here. Why don't we just use int32d here, int32d main? Why are you using a plain int here? Well, for legacy reasons. The main has been defined in C and C++ to be a integer as a return type. So that basically the definition how people has defined the main back in the days when the programming languages all started, like when C was invented, when C++ was invented, they defined the main function to have an integer as a return value. And well, that's the excuse for that. So the excuse for using a plain int here is because it's defined like that. In the standard, the int or the main function looks like that. So all nice or good. So nice excuse for that return value. But we also see another issue if you take a close look at that. You see that we never return something from our main, which kind of like seems to violate our rules that we have set. So you would expect me to write a return and then value here, for example 0. And this is what you basically expect. And well, let's maybe do this. Maybe let's return 50 and see what's going on. So if we return 50 and run our application, it does look like everything worked out as it should. So it's still giving us the same result even though we changed like the return value of that main function. And do we actually see what we returned here? Yes, we actually see it. We actually see it if we take a look down here at our debug output. So our output window, you have this error list and the output down here, which by default says show output from debug. So it shows you output from debug, and you can basically select what you want to show. You can like show build order, debug, source control, git, and you have a lot of options in here. And you can basically see that the program, simple C app.exe, has exited with code 50. So hexadecimal representation of 0x32. So you can kind of like see that everything that we are returning from that main here is somehow ending up down here. So if I would put this to 0, for example, and restart this, you would see if I minimize that now the application has exited with the code 0x0. And this basically is just how the application terminates. Visual Studio is nice and tells us that it exited with that certain code. And I think, can we also see it here? Yeah, you can also see it down here in the Visual Studio debugging console, which is the other Visual Studio behavior. You can see exited with code 0. And if I would go in just to entertain the possibility and run it again, you can see that it also returned now with code 50. So it kind of like gets reflected by Visual Studio, and that's nice and well, very, very serious, very, very easy to see. But does it really have a impact on our application? Yes, it has. By default, it does have none. There's only one rule that you have there, and this one single rule that we have is that if an application succeeds, it should return 0. 0 means no error, everything is good. But all other values are free to use. So you could basically define every value that you want to have for a certain error code. So if your application it count as issues. You could basically encode each issue in a number that you want to return, and then you can basically return them from your main loop, and kind of like you can see in Visual Studio why the application has failed. Now you would tell me, hey, but is it really helpful? Yeah, it's nice to see it. It's a nice gimmick that you can see it in Visual Studio, but is it really helpful? And yes, it actually is, because the Windows API, and also like the same thing on like Linux and like all the operating system APIs, the operating system APIs allow you to basically take a look and inspect this return value. So basically what you can do is you could do something like, this is now not real code. You could say something like launch app or run app, and you could say basically here, for example, simple capp.exe, and you could basically say int return code equals to run app. And what you then basically would be able to do, you would be able to inspect this return code. We're going to see how this works in the future, and you could inspect this and see if the application here, this run app, was successful. So basically it allows you to inspect the value also from a different application. That's very nice. That's really helpful to use. But we didn't have any return statement. When we started out, it looked like that. And that should be bad, because it's undefined behavior, right? We don't have specified anything. So what code are we going to get? Okay, we're going to still get 0 here. And we are also getting 0 here. But shouldn't that be undefined behavior? And you're right, normally this is undefined behavior. If a function doesn't return something, it's gonna fail. So for example, if we had this int, this function f here, if I would simulate this with an int fake main, something like that, and this fake main returns nothing. So let's just keep this fake main empty. And we would run it, you can see, or compile it. You basically can see that we, in the error list, get a warning, and we basically get the warning that fake main must return a value. You actually see that we don't get the warning for our default main. We're going to get to that in a second. And now, let's go back and go to the Solution Explorer. I'm going to select the simple capp.c, and I'm going to rename this again to CPP. So what happens now if I try to build this on C++? So I'm going to press Ctrl-Shift-B to build this, and wow, now we are not even able to build. Now the warning got an error, and it says fake main must return the values. So I already showed you that this doesn't work. So in C++ we really do need this return, but still C++ does not complain about the missing return statement in main. We can add it in main. So if I remove that and add like a return -1, for example, in here, would start this, it works with C++, no issue. But if we leave the return here away, even C++ does not complain. Normally C++ does not allow us to have no return value in a function. It just fails. There is one big exception to that general rule. There is one and only function that is allowed to have no return value, and that is the main function. Because in the C++ standard, and also in the C standard, there is a clause that basically tells if there is no return value in the main function, the compiler must append a return 0. So what the compiler basically does, if there is no return value in the main, it automatically adds return 0. So it's a very special thing for the main function, but it is there, and it's really useful so that we can have our main nice and clean. And also for starters, it's very easy to start with that. So yeah, that's actually quite interesting and good to know. So we made basically 2 mistakes against our conventions, and both of them were legit. Okay, and I think this is quite a nice introduction to functions. Now you actually have used your first function, you use the advantages of that first function, and that looks really nice. Do we have any other way of using a function? Yeah, let's actually create a new function. Let's create a function called void, and we want to call this printfx. Printfx is going to print the function fx. And if we want to print fx, we of course need some arguments. Insert it to t. I'm going to use an x and insert it to ty. So printfx should basically print out the x and y values. This is just because this looks a bit ugly, and if we would basically add a y4 here, for example, if we would add y4, you can see that it's getting ugly. We need to copy this over and paste this in here. We need to make sure that we have 4 times x here. We need to make sure that we have the y4 in here, and it's not really nice. We always need to figure our head around how this print function works here, how the call to print works, and we want to avoid this. We want to have nice and easy maintainable code. So now I also have this printfx function, and what I now want to do inside of this printfx, I basically want to make the call to the printf here. And we're going to make this one by just copying this over over and then adapting the function. So we're just going to do this x and y. Simple like that. Format, okay. And I'm just going to always have a comma and a space here so that we are always going to assert this format. This, of course, is now going to see that the last one also ends with a comma, but I really don't care at this point that we are kind of like using this, you could call it bad way, but no, it's actually not that bad way. And what we can now do is we can actually now call printfx here, and we can use like x and y, and we could duplicate this. I'm doing this with Control D. I think I already told you that. Can revert this, of course, with Control Z. And I can now put all these numbers in here. Like I could also make this like 1 times x just to indicate this, 2 times x, 3 times x, and 4 times x. The compiler is going to be smart enough to remove that times 1 here. And now the code really looks similar. Maybe I should also call this y1 then, to make this a bit more readable. Now the main code looks way simpler than what we had before. The print function looks way simpler than we had it before. And the function f also looks more simpler than before. And our application is nice and flexible. So you can see we are computing the y values, we are computing the x values. Sorry, we are setting the x value, we are computing the y by the calculated x values. Could also have the times 1 in here. And yeah, you can see we are now getting a nice row of numbers, and it's nice and easy formatted out here, and it's looking simple and easy to use. So if I would now press F5, we should still get the same thing, but with another number here, the 505. And as you can see, if we would now need to add a number, or we would need to print another function, so fx is basically just always like having that format, but it really does not depend on x, and it does not really depend on y. These are just plain values. You could have like a function f1, f2, and stuff like that to make this even more readable. We could also go in and add a name and add the name of this function as well. So we could have a parameter called name, which would be something like that. And then we could also add the name in here, but this is going to be advanced because this requires us to understand how strings work, which we really don't know yet. We just use them. So we can't really use them yet here. But as you can see, it's very simple, it looks clean, it looks nice. So we are done for today. We discovered functions. So final stuff to do is make a git commit, added functions. Okay, commit all. And if you want to directly do this from Visual Studio, you can click on that label, one outgoing, and click push here. We're just going to push this to GitHub, and your code is from now on available on GitHub, and everybody can take a look at this. Successfully pushed to Origin Master. So the code is online, everything is nice, you can take a look at this from now. And this concludes this video about functions. I hope you're going to learn something from that, and it was nice and easy to understand. And this is like sugar code. This is how simple your code should be, ideally. Okay, it can be a bit more complex, but this is like ideally to archive, because this code does not need any line of documentation. No single line of comments are actually required, just that we are currently simulating the input and we want to replace it. This is actually fine, and the IPO just for visualization for your tutorial is also fine. But even if you would not have them, if the code would just be something like that. And here I said that one is fine because we are like adding something that we want to do later on a to-do comment. It's okay. So even if the code would be like that, it would be still simple and still easy to understand. And it's like how clean code works. But for you, I'm going to revert this, of course. So yeah, thank you for watching. I'm going to hope you enjoyed it. And yeah, have a nice day. I'm going to see you in the next one. Make sure to like and subscribe, and bye.